Okay, number 12 says know how to write electron configurations using the shorthand method. All right, so let's take a look at that. If I wanted to write scandium, I don't want to draw out 21 electrons, so I want to use the shorthand method. So I'm going to go here to 20, 19. I'm going to go over here to the noble gas 18, and then argon is noble gas 18. I only need to worry about placing 3 more electrons. So let me show you what I mean. So if I were doing scandium, it has 21 electrons. So I'm going to put this argon, and everybody that sees that knows I'm talking about 18 electrons because that's what argon has. And then if I look at the periodic table, after argon, my next one is potassium, so that's 4s2. Oops, I don't write it down there. 4s2. And then if I go back to the periodic table, after 4s2, I'm in 3d1. So I want to place 3d1, and that saves me a lot of time. Okay, so let's do another one. We did scandium. Let's do something like, I think we should do, let's do tellurium. All right, so tellurium is number 52. So if I look at my periodic table again, 52, krypton would be my noble gas. It has 36. So I'm going to say, all right, tellurium is what I'm going to do. So I'm going to go with krypton. Krypton has the 36 electrons. So if I look at the periodic table, again, krypton is on 3. So I'm going to go to 4s2 and continue from there. So I'm going to have 4s2, 3d10, 4p6, 5s2, and after 5s2, if I look at it, I believe my next one is going to be 4d10, 4d10, and then 5p, but I got to figure out how many p's, so I go and count my electrons, p1, p2, p3, p4, so 5p4, and there is tellurium. So that's tellurium. Okay, pause it and look if you need to because I'm fixing to get rid of it. Next thing it says is how many unpaired electrons are in my nitrogen atom. So I need to figure that out. So I go to the periodic table. Nitrogen has 7 electrons. So I do 1s2, 2s2, 2p3. Those p's are going to be 1 in each of the little orbitals. So it looks like to me I have 3 unpaired electrons. The maximum number of electrons that can be placed in the d orbital is 10. Remember the s can hold up to 2. The p can hold up to 6. The d can hold up to 10. And the f can hold up to 14. Life on Earth is carbon-based. If life on another planet were based on another element, which would be the most likely choice to have properties the most similar to carbon? So I look at my periodic table, I pick out carbon. Silicon is the next one that is similar to it. So I would pick silicon because it's in the same family. The modern periodic table is arranged by increasing atomic number. Mendeleev arranged his table based on increasing atomic mass. And we now know that we see those repetitive patterns better if it's based on atomic number. A 2D sublevel does not exist, so the answer is 0 because there is no 2D. The Ds don't happen until we get to the 3rd energy level. Write the complete electron configurations for radon and chromium. So I go over here and I look up radon. It's got 86. So I'm going to go with xenon and figure that little rascal out. So let me kind of scoot down a little bit. So there we are right there. All right, so let's pull it back up. Okay, so I said, well, I'm going to do radon first. So radon is Rn. The noble gas configuration is xenon, which is, I think, 54. And then I'm going to go 6s2, 4f14, 5d10, 6p6. Notice these are lowercase letters, and these are superscripts. So I'm going to look at radon on the periodic table and make sure that I've got it good to go. So let's see. Here is radon, here's xenon, so I'm going to say xenon fills up the 5p6, so after that I'm going to go to 6s2, and then I'm going to scoot down here to 4f14, and then I'm going to come back to number 71, which would be my 5d10, and then I'm going to go 6p1, 2, 3, 4, 5, 6, 6p6. And that's what it looks like. All right, now I want to do chromium. Chromium is an exception. There are two of them. Chromium and copper have exceptions, and I'll show you why. Chromium is Cr, and so I want to do the noble gas configuration for that, and so it's going to be argon. Then I would go 4s2, and then I would go 3d4, but since it's an exception, this one has only one. And it gives that extra electron to 3d to make it 5 because 5 is more stable. It's half of 10, so it's more stable than a 4. So that's the exception. Copper works the same way. If you look at copper, it has right here 29 electrons. So I'm going to go with argon. Argon. And then I'm going to go 4s2, 3d9. But this is not as stable as having 3d10, so the 4s says, hey, take one of my electrons, make that be 10, we are stable. So this one is an exception, and chromium is an exception. Those are the only two exceptions you need to worry about, and you do need to worry about them because you may see them on a multiple choice. Be careful. Chromium and copper are the exceptions. Okay, going to get rid of that. This one says, which element has a partially filled F subshell? We'll go find the F's on the periodic table. Is the easiest way to answer this. So here's my F's. Here's my F's. All right, so let's go back. We had our choices were barium and europium. So let's do those first. Barium is Ba. Barium is right here. It's not in the F. Europium is Eu. That's in the F, so I think that's going to be my answer. Then I'm going to look at the other two, rhenium and bismuth. So rhenium is the Re. Let's see where Re is. It's going to take me a few seconds to find it. Re, right there. It's in the D, so that one won't work. And then Bi is my other one. It's over here. It's in the P. So the only one that's got an unfilled F is europium. So I'm going to pick europium as my answer, and I'm going to be correct. What is the total number of p orbitals completely or partially filled in a Gaussian silicon atom in its ground state? Well, first I got to figure out how many electrons are in silicon. So I look at silicon, it has 14. So I say, well, I have 1s2, 2s2, 2p6, 3s2, and I think that's 3p2. Okay. Now it wants to know the total number of p orbitals, so I have to be careful because I have 3 p orbitals there, and I have 2 there, so my correct answer should have been 5. And when I did it initially, I circled 2, but that's wrong. It doesn't say in the outermost p orbitals, it says in the p orbitals period. Well, there's 3 there, and there is, for that one, 3p. I have 1 here, and 1 here. So be careful. Read them carefully. This one's partially filled, this one's partially filled, so that's 2, and then 2p has them all filled because it's got 6. So there's completely filled 1, 2, 3. So I have 1, 2, 3, 4, 5. So that's why the answer is 5. For which element is the last electron added to a d orbital? Well, I have to figure out who's in the d orbital, so I go back to my periodic table and I look at barium. Barium is not a d orbital, so I say, not that one. In D, and I can't remember how to say that one. There we go. Let's see what it says. Neodymium, that's an F, so that one won't work. My next choice is hafnium, HF, and I got to find HF. There it is right there. That one looks like a possibility because it's in the D block. Then my last one is lead. Lead is over here in the P block. So my correct answer is hafnium. Of course, you'll be seeing these and shading your SP, D, and F like you did on the worksheet. You need to study everything you've done. Good luck.